in the diagram, AB is equal to 5A, AD is equal to A minus B, and DC is equal to 7A minus 2B. Express in terms of A, B, and or C in simplest form, the vector AC. So here we have this diagram, and our goal is to determine in simplest form what is the vector AC. Now AC means that we start at A, all right? We start at point A and we end at point C, okay? And so AC is going to be equal to AD plus DC. Now why does that make sense? So we start at A and we go to D, all right? So that's where we have the AD, and then we go from D to C. We go from D to C. And so that means that AC is equal to A to D, which we have here, and then it goes from D to C, which we have here, all right? So AC is equal to AD plus DC. Now, what is AD? Well, based on the diagram, AD is equal to A minus B, so we put that in. So A minus B, that's what AD is equal to, A minus B. And DC, well, DC, so we go from D to C, DC is equal to DC is equal to 7A minus 2B. So DC is equal to 7A minus 2B. And so we have AC is equal to A minus B plus 7A minus 2B. Now what we have to do is we have to group our like terms. And so we have A plus 7A. So we have A plus 7A. And then we have negative B minus 2B. So we have a negative B minus 2B. And so that's what AC is. AC is going to be A plus 7A. That's what we have here. And then negative B minus 2B. And so what we do here is we add. So we have A plus 7A. And A plus 7A is simply 8A. And then we just bring down the negative B and negative 2B. Then we operate on these. So we say negative B minus 2B is equal to negative 3B. And so that means that the vector AC is equal to 8A minus 3B. And that's the answer to this question. Next, we have to determine what is the vector BC. And when we have the vector BC, what does that mean? That means that we start at B, all right, and then we end at C, all right? And so we go from B to A, all right? And so that's what we have here, B to A, and then we go from A to C, A to C, all right? And the reason why we put A to C is because we already know what A to C is. We figured out what A to C is in simplified form in our previous question. So we can go from A straight to C because we figured out what that was. We don't have to do, oh, AD, what is that? And then DC, what is that? And then, add them up again and simplify. We don't have to do that. We just get use the result. And so we know explicitly what is AC. And so we're going to use that answer in this question. But what is BA, right? What is BA, right? If we notice carefully that BA is actually equal to, BA is actually going in the opposite direction, right? It's going in the opposite direction of AB, right? So BA is going in the opposite direction of AB. That's why we have this negative sign, because BA goes in the opposite direction of AB. So we have the negative sign. Now, what is BA? Well, sorry, what is AB? Well, AB is 5A. So AB is 5A if we're going in this direction. But we're going in the opposite direction. So BA is going to be negative 5A. And it's negative 5A because we're going in the opposite direction. All right, so that means that BA is going to be negative 5A. And what is AC? Well, AC, we just figured out we just figured out what AC was earlier. AC is equal to 8A minus 3B. And so we have that BC is equal to negative 5A plus 8A minus 3B. And so we have to group together our like terms. So we have negative 5A plus, so we have a negative 5A plus 8A minus 3B. And what is a negative 5A plus 8A? Well, negative 5A plus 8a is going to be positive 3a, and we bring down the negative 3b. And we can factor out a 3, right? So we can factor out 3. So we say 3 open bracket a minus b. And that makes sense because if we take this 3 and multiply it by a, we get 3a. And if we take this 3 and multiply it by negative b, we get negative 3b. And so this is this answer is our answer to this question in factorized form, in factored form. Okay, so let's move on to the next part of this question. It says that write down two geometrical properties of AD and BC. So they only want us to write down two geometrical properties of AD and BC. Now, what is AD? This right here is AD. And what do we know about AD? Well, AD is equal to A minus B, all right? And BC, what do we know about BC? Well, we just figured out BC, right? We know that BC is equal to 3, open bracket, A minus B. And so let's go ahead and write down two geometrical properties. Let's answer this question. So what do we have? Well, the first thing that we need to pay attention to is what is BC and what is AD. We know that BC is equal to 3 open bracket A minus B. That's what BC is, right? And we also know that AD is equal to A minus B, okay? And so if we have here, we have BC is equal to, like we said, 3 multiplied by A minus B. And that's what BC is, 3 multiplied by A minus B. But interestingly enough, if we look carefully, right? If we look carefully, we notice that, hey, guess what? A minus B, we know what A minus B is. A minus B is actually equal to AD, right? That's what AD is, right? So AD is equal to A minus B. So if we have BC is equal to 3 times A minus B, instead of writing A minus B, let's write AD, right? So let's write AD. And so we actually have is that this is equal to 3 times AD. So what that really means is that BC is actually equal to 3 times AD. So we have BC is equal to 3 times AD. And what does that mean? That means that if we multiply 3 times AD, we get BC. And so that means that these two vectors, that means that the vectors are scalar multiples of each other, because we can take the scalar, which is 3, and multiply it by AD, and we get this vector. So since BC is equal to 3 times AD, this means that the vectors BC and AD have the following properties. What are the properties that they have? The first property is that the vectors BC and AD are parallel. Now, how do we know they are parallel? Once we can take one vector and multiply it by a scalar, and that gives us the other vector, that means that the two vectors are parallel. That's what it means to be parallel. Parallel, two vectors are parallel if they are scalar multiples of each other. All right, so these two are scalar multiples of each other because we could take one vector, AD, multiplied by a scalar, and that gives us BC, the other vector. So the vectors BC and AD are parallel, right? So that's one property. The next property is that the vectors BC and AD are scalar multiples of each other. These two mean the same thing. If they are scalar multiples of each other, then they are parallel. So these two things are saying the same thing. And then the third one, the vectors BC and AD have the same direction, and vector BC is 3 times longer than vector AD. Now they only asked us for two geometrical properties. And so the two geometrical properties that we would use is the first one. Number one, vectors BC and AD are parallel. And number two, vector BC is 3 times longer than vector AD. And so, or you could use the third one, the vectors BC and AD have the same direction. You could also use that, but they only asked us for two. So we're going to use these two. The one that says that they are parallel and the one that says that BC is 3 times longer than AD. And we know it's 3 times longer because this has the 3 right there. And so that's the answer to this question.